For this review problem, state and prove the rule for checking that a number is a multiple of 4. To do this, it's actually the fairly straightforward theorem. So let n be written in its usual base 10 representation, a sub I minus 1 times 10 to the I minus 1 plus a sub 3 times 10 to the third plus a sub 2 times 10 to the second plus a sub 1 times 10 to the first plus a sub 0. Then 4 is a factor of n if and only if 4 is a factor of the number form from the last two digits, a sub 1 times 10 plus a sub 0. So the only thing that matters for checking if a number is a multiple of 4 are the last two digits. Proof. So note that suppose I were to take just the first, all the digits except for the last two. Then this is equal to, well, one obvious simplification that I can make is I can factor out 10 to the second. So 10 to the second times whatever's left, a sub I, times 10 to the I minus 3 plus a sub 3 times 10 plus a sub 2. Now everything in the parentheses is an integer. 100 is equal to 4 times 25 times this same integer, whatever it is. So the practical upshot is that if I take the digits, the number formed by just dropping the last two digits like this, it's a multiple of 4 because it's also a multiple of 100. So that's the important observation. So 4 divides n if and only if 4 divides a sub I minus 1 times 10 to the I minus 1 plus a sub 2 times 10 squared plus a sub 1 times 10 plus a sub 0. And from a theorem we have in class, that this number is a multiple of 4 if and only if that the same number minus, sorry about that, let's try it again. The same number minus a multiple of 4 is a multiple of 4. And clearly the multiple of 4 that I'm going to choose is a sub I minus 1 times 10 to the I minus 1 miswrote that. Parentheses should go here. Through a sub 2 times 10 squared. So the number in parentheses is a multiple of 4, so 4 is a factor of this mess, if and only if 4 is a factor of the same mess minus this known multiple of 4. And clearly when I subtract, what's left is going to be that 4 divides the last two digits, which are not canceled when I subtract, a sub 1 times 10 plus a sub 0. And that is the end of the proof. It is possible to replace the 10 by a 2 by subtracting 8a sub I. The logic would also work. As far as the logic works, it doesn't do much practical help when checking the if a number is a multiple of 4, but that is technically correct as well.